Wait, can you hear me? Okay, I'm sorry. Okay. So, um, for today's class session, me and Alex will be discussing the topics that from the math videos. So I'll be discussing the first half of 9.3, and Alex will be discussing the other half. Okay, so in the video, initially Tom um, proposes the question: does the series from n to 1 to infinity, does that series converge? And from the series of 1 over n, does it converge? And so he evaluates this by finding the term and finding the value of each term the value of each term in the series, and soon to emphasize that as the terms in the series increases, so does the value. It doesn't seem like it's converging to a certain number, a finite number. So um, so essentially this series does diverge. And so he further explain, give a graphical image to explain it. I'm gonna share it right now, and let's try this. Let's see if it works this time. Yes, perfect. So he draws it onto this graph. So each term in the series is a certain bar to represent the area, and he compares that with the like an actual function with the same idea. So 1 over n equals 1 over x. And so with this, you're able to estimate the values of um, the series. So in this example, it shows that for the function 1 over x and for the series 1 over n, the series left approximates the function and overestimates. And so from this example, he emphasizes that um, as a function continues, the individual sorry, I just blinked for a second. Okay. So in this example, you can see that the series overestimates from the um, from the function 1 over x. And so essentially out of this, he came up with the idea. So if as a let me just go to the next example that he gives, which is the same idea, 1 over x squared and the series 1 over n squared. And so in this situation, it left estimates. It right estimates but underestimates. And so essentially from this entire from these two examples, he evaluated the integral test, in showing that if the integral is decreasing and positive, then the following rules, or the following ideas will work and when testing it. So if the function, so if the integral, if the integral converges, then the sum will also converge. But if the integral diverges, the sum will also diverge, or the series. And essentially, like you can tell from the examples, the one thing that's different, and one thing that's emphasized between the integral and the series is that the value of the two will not be the same, or theoretically will not converge to the same number, because in both examples, it's either underestimate or overestimate, emphasizing that the values will not be the same.
Quick question. So the theorem regarding the integral test, that only is true if the function is decreasing and always positive, right?
Yes.
Okay.
Okay. That's basically it for 9.3. Here are the Here's the theorem if you want to get a better look at it. But yeah.
All right, cool. So, oh wait, do you have any more questions? I don't want to just jump in. All right, cool. So for 9.4, this is basically a test for when the series you're working with is, it still has to be positive, but it doesn't have to be necessarily monotonic or monotone. Is monotonic a word? Okay, so
Yeah, I think it's monotone. Just monotone.
Okay.
That's like the adjective.
okay. So essentially, the idea is that when you have a series and you decrease every term in the series, that the overall like behavior of convergence still remains. So like the example that Tom used in the video is 1/2 to the n. And so we know that 1/2 to the n converges. And so like the rule is basically if you take every term in 1/2 to the n and decrease it slightly, that series will also converge, which means that, you know, the series of 1/2 to the n plus 1 converges as well. Although it'll be overall lower, it'll also converge. And so, you know, going a step further, because changing a finite amount of terms in the series doesn't change the overall behavior, then that means if you have you know, like if you have a equation or a series and it's changed slightly, as long as the overall trend is that each term is decreasing, you can have a certain amount of terms that are increasing and you'll still be converging. So you won't change it too much. So it's basically just kind of a way of just almost immediately telling if something is converging based off of your knowledge of the like the general form of the series.
Cool. That it? Is that it?
Yeah, I guess so.
Alrighty.
Any questions?
Yeah, any questions before I stop recording?
Can I ask a question?
No.
Yeah,
If
sure.
you have something like, so you said 1/, and then it's in parentheses, 2 to the n plus 1, that also converges, right?
Right.
So if you had like 1/, in parentheses, 2 to the n minus 1, could you use the test there?
No, because that would be increasing,
Okay.
I believe.
And
Yeah.
and if you increase it, you wouldn't know. You
Yeah,
can't tell at this point if
Right,
it's
you wouldn't be sure.
continue converging or
exactly.
diverge.
Sounds good. Okay.
Thank you.